All right, so we talked about these clouds or blurs that the electrons are moving in. Electrons are moving crazy mad fast. All right, so we talked about these clouds or blurs that the electrons are moving in. Electrons are moving crazy mad fast. All right, you ever see Ant-Man?
Yeah.
Crazy mad fast.
That annoys me so much.
Does it?
Because
Okay, good.
it's
I'll
the
keep on
same
using
amount
it.
of atoms. It's like he's always the same amount of atoms, but when he shrinks, he gets lighter. But it's the same amount of atoms. It's just like held closer together. So it's just like he has a keychain tank that's 20 tons, and he has it in his pocket, or you know what I mean, like a whole building.
Oh yeah, I do. So that's the issue of when you shrink matter, the matter's still there. How could it weigh less? But we'll talk about that. That's Ant-Man. Right. But clearly, you know, that's the one messed up part about the Marvel universe, because everything else makes sense. Okay.
That one just really got to me when I saw the movie. Like I couldn't enjoy the movie.
What really got to me is they can cut off Wolverine's claws. I will not accept that. I would.
Didn't we go over that?
You can't do that. You cannot do that. And it's not vibranium, it's adamantium. But don't get me mad right now. I have to teach. Correct. The shield. So, Schrodinger made these wave equations, and I told you that an equation is a shape, understand? And these are called, honestly, they're called high density probabilities. I've said that before, yes? The probability there's an electrons moving in that shape, right? So we're gonna see what these shapes look like. All right, so these shapes are called sublevels. We have an energy level, and we talked about that yesterday. We proved yesterday that there were energy levels. Agreed? Yeah. All right, the electrons cannot be in between levels. They have to be on an energy level. But in an energy level, we're gonna say that there are shapes that the electrons move in. And those shapes are called sublevels. Okay? Sublevels. And we'll talk about these shapes. The first one is the easiest. Alright? You guys are familiar with the XYZ coordinate? Yeah. Alright? The first one is just a sphere around the nucleus. Alright, this is called the S sublevel. S sublevel. You understand a sphere? You understand because it's kind of just going around in a sphere. Around the center is the nucleus. Is that clear? Yes? Okay. So this is called S sublevel. All right. Also, I'll have to teach this next one first. There's only 4 of these, so it's not that bad. The second one is called the P sublevel. The P sublevel. All right, and the P sublevel is made up of 3 of the same shapes. All right, they're called orbitals. All right, one of them looks like a dumbbell. What's a dumbbell look like?
The thing you left, it looks like an H kind of. Like that. Sure.
Okay, clearly scientists don't work out, all right? But it's one of those dumbbells. Understand? For your bicep. You can use them for many things, okay? All shoulder muscles, right? These are, those are the muscles. Back muscles if you do rows, like this, all right? But either way, they're dumbbells, okay? You know what? It just looks like a figure 8. The nucleus is in the center, so the electrons are moving around in that shape. Are you with me? But the P sublevel has 3 of these shapes going on. One on the x-axis, one on the y-axis, and one on the z-axis. Do you understand? There are 3 of them in space. Yes? Each of those is called an orbital. Each of those is called an orbital. All right.
Can we put on more of the Disney instrumental?
Nope. That mumbling bothers me. It's like when you guys answer me. Shh. Okay, and listen, here's a rule, ready? An orbital can only hold 2 electrons. An orbital can only hold 2 electrons. Any orbital, all right? So the s sublevel only has 1 orbital. Understand? It's just 1 sphere. Okay? The p sublevel has 3 orbitals. So how many electrons can a p sublevel hold?
6.
That's correct. How many can an s sublevel hold? 2. That is correct. Are you with me? Okay? And I'll never ask you to draw it, because that means I have to grade your drawing.
What is this?
What?
No, that's what you say when you read it.
What did he say? Are you taking notes on a whiteboard?
Yes.
What the?
I think take a picture of you.
What is the z axis?
The one that sticks straight in and out of the board. Do you understand math? Graphing, 3-dimensional graphing, the XYZ coordinate system?
Oh, okay. Yeah.
So there's a p orbital going x, there's a p orbital going y, and there's a p orbital going z. Understand? It's just three-dimensional axes. You guys have done this, right? Huh.
That's calculus.
It is not. Okay, whatever.
Agree to disagree.
There's so much more math for you guys, but that's one way to show 3-dimensional space. XYZ axes, it's called. Right? Okay, the next one is called a d orbital. D sublevel. All right? And the d sublevel has really pretty orbitals. They kind of look like this. It's like a 4-leaf clover. And that one is on the XY plane. That's flat. Understand? Yes? That's 1 d orbital. Guess how many d orbitals are in the d sublevel? Huh?
1.
It's interesting. You have 1 here. How many here? 3 here. 5 is correct. There are 5 of them. All right? They're going to go on this plane, this plane, this plane. All right? It gets complicated. There's 5 of them. But they look at 4-leaf clovers. There's a picture of it right there. And one with a dumbbell with a ring around it. Okay? All right? I'll draw them all in. Have fun.
Oh, God. Oh, that's beautiful.
Whoa.
Stop. I practice.
It's hard.
I can tell.
There are 5 d orbitals in the d sublevel. Yeah, just put all these together into one picture. And that's what you'll see. It doesn't really matter. Just know that there are 5. Okay? Again, I'm never going to ask you to draw it, but see that they all go together. Okay? Yes? So how many electrons can a d sublevel hold? 10. Okay? And the last shape, the last probability density, the last wave equations pertain to this shape. And it belongs to something called the F sublevel. Guess how many orbitals there are in there?
7.
Yeah, 7. Very good. And how many electrons can it hold?
14.
That's right, it can hold 14. Okay. And one of them, it actually looks like it has 8 lobes in it, and it goes 1, 2, 3, 4, 5, 6, 7, 8, in a kind of like chrysanthemum flower thingy. Okay? The book can't even draw it, but I can. I practice. Okay? Just think of it as a 8-lobed chrysanthemum flower. coming out of the center. Bless you. Okay? And that's one of them, but there are actually 7 altogether. All right, so if I had to draw it all together, it gets crazy mad complicated. All right? Okay, do you see how that's just 2 of them? Yes?
Yeah.
And if I draw the rest in, yeah, it just kind of gets a little, yeah. Okay,
Oh my god.
Stop.
what?
You're gonna hurt Danny.
That's the way it looks. Yeah.
I need to remove those 2 eyes.
Oh my god, you know how in Alice in Wonderland there are these flowers and they look like cats? That's what that looks like. It's crazy. Alice in Wonderland. Do you not see the ears and the
Never.
eyes you put on there?
He did it on purpose.
I know, but I'm just saying.
I would never be able to shoot me.
Somebody thought you could No, I tried
It's
to
not
be a
halal.
vegetarian. No, it lasted for 8 hours.
8 hours is too long for me. The only 8 hours I don't eat meat is when I'm sleeping.
I don't see
In between bites.
Okay, everybody hear what I'm saying? Yes?
Yes.
Okay, so again, I'm not asking you to draw it. I'm just you got to remember the important things. These are called sublevels, and different sublevels have different number of orbitals, and therefore they hold different number of electrons. You got me?
Yes.
All right, so let's remember what an atom looks like. You have a nucleus, and you have these energy levels. All right? So let's talk about where the electrons go. All right? So if there's an electron in the first energy level, I just want to tell you, you've been using the word shell, which I don't like, but that's okay. All right? It is kind of a shell around the nucleus. It's protecting the nucleus. The first energy level only has an S sublevel. That's all it has room for. So how many electrons can the first energy level hold? 2. That's all. You know, it's small. It's really close to the nucleus. It's not a big amount of space. Understand? And it's only at 1 S sublevel, therefore only 1 orbital. You got me?
Yes.
And if I were going to draw it, and imagine these are X, Y, Z coordinates, it's just a sphere around the nucleus. Get it? Yes? The second energy level, which is farther away and having higher energy, because it's farther away from the nucleus, guess what it has?
S and P.
A S and a P. So how many electrons can the second energy level hold? How many? 4. Absolutely wrong.
6.
8 is correct. Because why? Do you understand it? You do? How many electrons can the second energy level hold? Andrew. Why?
Because it has a sublevel S and a sublevel P. There's 4 orbitals between them, and each orbital can hold 2, so it's 8 electrons.
There you go. See what I'm saying? I need you guys to understand this. Yes? Okay? What's that look like? Well, the 2S, second energy level that has S, looks like a sphere. It's a bigger sphere, clearly, because it's a higher energy level. Yes?
Yeah.
Right? And it has a 2P. Are you with me?
Yes.
Okay. What? The third energy level, what do you think that has? SP and a D. And how many electrons do you think that can hold? How'd you get 18? S holds 2, P holds 6, D holds 10. And the fourth energy level holds what? How many electrons can that hold? 32 or 36? He said 32.
18 plus 14 is.
How many?
8.
8. Everything okay over there? Okay? What do you think the fifth energy level holds?
One more S. 2 S's, 1 P, 1 D, 1 F.
Absolutely wrong.
Great.
But that's a good try, though. It's logical.
Because when
How can it have 2 S's? If you think about it, that's the space where the first S electrons are moving. How could a second set be moving in the same space? You can't. So in any energy level, you can only have one of each sublevel.
So it's just SPD.
Yeah. It's the same from then on. 5, 6, 7. It's all the same. Okay? Question? Question?
It's the same. What do you mean by that? What would the fifth energy level look like?
A bigger one of the fourth.
Oh, okay.
Further out.
Right.
But you can't have 2 of any sublevel because that's the same space that something else is using. Does that make sense?
Can you give us that like what you know quiz a really long time ago? Does this have to do with the thing with the arrows and the S?
Yeah. That's what I'm about to teach. Okay. Everybody okay with that? All right. Everyone understand how these stack onto an atom? Over and over. So this is the 3s, right? It's a sphere. It's a shape, right? Remember, these are just shapes. How big they are and what energy level they're on vary, but they're the same shape, bigger or smaller, on which energy level, right? 3s, 3p, right? And you don't want me to do a 3d, do you?
No.
Okay, so we'll leave that pretty like.
Do a 3D.
Okay, you don't want me to see, you don't want to see a 4f on top of everything, do you?
Yes.
Oh no.
Do 5.
Okay? Okay, everyone with me so far?
Yeah.
All right, everyone get a periodic table out. I need you to see a periodic table. I need you to be looking at it. I need you to be rubbing the periodic table. It's going to be your best friend.
Oh, there's an extra one here.
All right. Talk about electrons jumping up and down. We're going to talk about something called ground state. Electrons want to be lower energy levels or higher energy levels?
Lower.
Lower, because that's why? Low energy. Okay? That's actually, someone figured that out. His name was Aufbau. A-U-F-B-A-U. That's called the Aufbau principle. Electrons will stay in the lowest energy levels possible. All right? The second rule, and you guys can look at me all you want, states that you can only have 2 electrons per orbital. 2 electrons per orbital. That's called the Pauli exclusion principle. Pauli, P-A-U-L-I, P-A-U-L-I, Pauli exclusion principle. We'll explain these a little bit better later, but that's kind of important. 2 electrons per orbital. So, let's take a look at the first element. What's the first element?
Hydrogen.
Hydrogen. How many electrons does it have? 1. How do you know?
There's one proton.
The atomic number.
So I won't take that answer. Atomic number does not talk about electrons. Raphael?
Because when you know the atomic number, you can know the amount of protons in it and you know the
Okay, never mind. I got never mind at the end. Anissa?
The number of electrons has to equal the number of protons for it to be an atom. And since it says the atomic number is 1, then you know the number of electrons is 1.
Correct. That's the correct explanation. See what I'm saying, guys? You have to be very sure of what you're saying, and you have to understand the words well. Don't say it has 1 electron because the atomic number is 1. That is not correct. See what I'm saying? Yes? All right. So, if there was 1 electron, where do you think it would be in the atom?
In the first orbital.
Huh? Which energy level? First. And where would it be? Which sublevel?
S.
How many electrons?
1.
1. So this is called an electron configuration. This tells me where every electron is. Okay? So for hydrogen, I would go like this. Hydrogen, first energy level, S sub level, 1 electron. In the first energy level, in the S sub level, there is 1 electron. Everybody see what I just did? Okay? So, let's continue. How about helium? The next one. How many electrons does it have?
2.
How do you know? How do you know? I thought we just went over this. Ray?
Because we know that an atom is a neutral charge, and if the helium atom has 2 protons, therefore it must have 2 electrons.
Bam. I'm sure you guys can figure out how to say that faster. Okay, but yeah, simply, right? So what do you think those electrons are? If I had to say where are the electrons in helium's atom, what's the electron configuration for it? What would you write?
First energy level. S.
There you go. Okay. Yes? Everybody? What's the next element? Lithium. How many electrons does it have?
3.
Why? If it has 3 protons, it must have 3 electrons to be neutral. Okay?
Yes.
Ooh, who wants to try lithium? Dakota.
1 SP1.
Wrong.
2 SP3.
Wrong.
1 S, 2 P1.
So close.
1s2, 1p1.
There's no 1p.
2
There's no p. So you can't say 1p. You can say IP. Kim.
2s2p 2p1.
No.
2s2p1.
Wrong. Ready? Oh, we're gonna try again?
1 S2, 2 P1.
Almost.
1s2, 2s1.
Correct.
1s2, 2s.
Questions?
Why is it S?
I got 3 electrons that want to go as low as you can. Right? After 2 electrons, the 1s is filled. The first energy level is filled. Can any more fit in that? So the next electron has to go where?
Oh. Okay. Second energy.
That's right, the second energy level. Therefore, you better say 2 something. 2. And then which sublevel is going to go in?
S.
That's right, the S is the next one. Not the P.
Oh, wait, how's it?
You have to look at how much the lowest that it would fit.
And how many electrons in the 2s orbital? 1. So 1s2, 2s1. Questions?
How are you able to use 2 S's?
What 2? There's 2 different s's, 2 different energy levels.
So you can use S on various energy levels.
I'm not using S. There is
There
an
can be.
S on every energy level.
Okay.
There is not a P on every energy level.
Oh, right.
That's what I just went over here.
Right.
Are you with me? You gotta focus here. You gotta focus. Now your flower. Happy Valentine's Day. Who gave those to you? What does one red and one white mean?
I don't know.
I love you, I hate you.
She probably just slipped on ice.
I love you.
She slipped on ice and one of them turned white. What's the next element? Beryllium. Who wants to give me the electron configuration for beryllium? Najma?
1s2, 2s2.
Correct. What's the next element? Boron. Who wants to try boron? Sebastian.
1s2, 2s2, 2p1.
That is correct. Questions?
I have a so the number in front of the S or the P that is simulates the electron shell, right? And which one it is in?
It's the energy level, man.
Okay.
Also known as a. You can say shell, but it's the energy level. And remember, energy level is how far away from the nucleus. Yep. I like to separate it out because people get confused and they start trying to read a word. Okay? Someone explain to him why we went to 2P1. Who can explain why we went to 2P1?
So, we filled up the S sub levels, and you can no longer use them again. So you have to move on to the 2P because you've got there. You can use 2 for 2 sub levels for S, but you can't have 2. You've already used up the
complicated.
S sub levels, so you'd move on to the second P level, and you use one of those because you've already used up 4 electrons.
Do you understand that? Okay, first of all, the way you guys say it, you used it up. No, it's filled.
Okay.
When an orbital is filled, no more electrons will fit. It's not used up. Okay? Gabe, you want to try?
Oh,
Yeah.
The S sub levels are filled up for energy levels 1 and 2.
Filled up with what?
Electrons for energy levels 1 and 2. And the next orbital that you can go into is the P orbital.
What P?
P level 2.
2P.
2p. And you would put 1 electron there, so that's why there's a 1 next to the P.
Can you fit any more into the 2S? Why? Yeah. So where's the next one go? What's the next available spot? You with me? What's the next element? Carbon. Gabe.
1s2, 2s2, 2p2.
Correct. Next one. Nitrogen. Who wants to try that? Nia.
1s2, 2s2, and 2p.
2B3, correct. You didn't say I love you. Okay, what's next? Oxygen.
No, we're just gonna go for 4.
Geo.
No, it's alright.
Oxygen.
You do you.
You could do the last one, you can't do this one.
1s2, 2s2, 2p4.
How's that?
That's good. I know. I didn't need your validation.
That's Star Wars. I love you. I know. You guys watched Star Wars before?
Yes. Yes.
Oh my god.
No. How have you never seen Star Wars? How have
Okay.
you?
It's kind of funny. It's like a really tender moment when she goes, "I love you," and he's about to like be lost forever. He goes, "I know." It's beautiful.
That's just because.
It's not you, it's me. What's that for auction? Gimme. Dakota.
1s2, 2s2, 2p5.
Correct. What's the next one?
Neon.
Neon. Anybody? Anybody? Shh. Raphael.
1s2, 2s2, 2p6.
Very good. Next one. Gabe, have you done one yet?
Yeah. Danny.
You right. Danny!
1s2, 2s2, 2p7.
Oh,
Hold on. 1s2, 2s2, 2p6, and then D. No, 3d1. Oh, 3s1. Oh my god. Don't worry about it. No. Can I say it again?
Please, because I'm having an aneurysm.
1s2, 2s2, 2p6, 3s1.
Correct.
Okay.
Say thank you, Sebastian.
Sebastian.
Sebastian. For letting me sub for Isabel. Notice, when I add up all the little numbers up top, they better equal the number of electrons. Yes? Magnesium. Dakota.
1s2, 2s2, 2p6, 3s2.
Correct. I'll do one. What's after magnesium?
Aluminium.
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 That's British.
That's how you say it.
Aluminium.
Aluminium.
Aluminium. You want to try, Kim? Yeah, with a British accent. Go.
1, 2.
What the? Okay, next. 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 Dakota.
I can't do the accent.
2p6, 3s2, 3p1.
Correct.
Can you do radon?
I can. You ready?
Copyright.
Yeah. Yep.
Radon is 80s.
I'm gonna do radon. Ready?
Yes. Radon is 80s.
Follow along with me.
Yes.
Wait, hold on. 86.
You're gonna be able to do this after vacation. Ready?
Whoa, I can do it right now.
Right.
But I'm Geo.
No, I don't know you yet. I don't feel comfortable. Ready?
Yes.
Follow along. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, 7s2.
I have no idea what the heck you just
Yeah, I don't know.
One time,
Yeah, we even know right?
That's my point. I could have said anything, but it was right. I know I'm right.
Can you just
So it doesn't have to go in order as long as you get all of them?
No, it doesn't work that way.
it has to.
It doesn't work that way.
He didn't say that.
What's the matter? Oh, you want to see the trick on the table?
No, like, I think.
I'll show you a trick on the table. Gather up.
Yeah.
Okay, so how many columns are here?
2.
2. How many columns over here? This block right here.
6.
6. Interesting. How many columns are in between? Oh, that's a 10. How many are down here?
Many.
12. I don't know. 15.
It's 15. You're right, but actually these two belong up here. Okay, they just pulled it out.
So then there's
No. 15 minus 1 is
14.
14. Oh, let's wait. How many here?
2.
2.
6. 10. 14.
Do those numbers seem familiar?
Oh, yeah.
A little bit, yeah.
Oh. The amount of electrons that could go
Oh!
Electron configuration.
1s1.
1s1. What was the last electron configuration for lithium? Do you remember?
2s1.
What was sodium?
3s1.
Wait, 1s1, 2s1, 3s1? Huh. What do you think this is?
4s1. 5s1.
Shocking.
1s2.
2s2. There's no 1s2 is over here, but which really should be over here, but it's an open gas. 2s2?
3s2. 4s2.
Interesting. What's this one? What's it end in?
2p1.
2p1? 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. Interesting. What do you think this one is? 3p1. 3p1? Huh. S's start where? What energy level? 1. P start at what energy level? 2. P doesn't show up till 2, right? So that's the first P. That must be 2p1. Agreed?
Yeah.
What do you think this is?
3p1.
No, that's 3p1.
Oh, wait.
3d1. That's the first D. What energy level?
4. 3.
No.
3.
It's 3.
That's 3d1. So that's
41.
4d1. This is 3d2. 3d10.
Oh my god.
Interesting. And down here, what are these? That must be
4f1.
4f1. Up to 4f14. Remember, this one belongs up here, right? 71, 72, right? They just pulled it out to make that space to show that that belongs in between. The reason why they don't put this in is because the poster is going to be really long and with a lot of empty space. All right? But it belongs, this belongs stuck in there. Is that clear? Just like this is stuck between these two. Okay? Wow. Ready? Pick one for me to do.
Lauren Colleen.
I need you to learn from it instead of going, ooh, he can do it.
Cesium.
Yeah.
Cesium? Watch. Watch. All you guys who are not watching, you're going to pay for this. All right? Cesium. Ready? I'm going there. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. This is a 3D. Follow along. 3d10, 4p6, 5s2, 4d10, 5p6, 6s1.
Shocking.
Follow the chart.